So good morning students. So today we are going to discuss the toppers JEE NEET Foundation 9th class light lesson. Light energy. See, one light is a form of energy which is emitted from the self-luminous bodies. The bodies which emit light are called self-luminous. Light is produced when there is a transition of electrons which produces the light, the energy which is released, and the light so travels from one place to another place. That radiation, light radiation we will call. So there are some concepts in the light. We have reflection, refraction, so interference, diffraction, and polarization. There are different phenomena of observed phenomena of light. So there are some questions which are related to the light we are going to discuss in this session. Ninth toppers, so light lesson. There is a first question: which of the following phenomena contributes the significantly the reddish appearance of the sun at sunrise or sunset? See, which of the following phenomena contributes significantly to the reddish appearance of the sun at sunrise or sunset? Sun during the sunrise or sunset, so the reddish appearance we observe. See, that reddish appearance is, if you observe, see the reddish appearance we observe, the light. See, due to the option A, dispersion of light or scattering of light, total internal reflection or reflection of light from the earth. See, the dispersion is splitting of light. See, that is no way connected with the, so the question was the scattering of light. The scattering of light is nothing but, it's a whenever light energy is incident on the air or gas molecules, so there is a some absorption of light and the process of re-emission of light. The process of re-emission of light when a light incident on some molecules, this process we will call it as a scattering. The scattering is the reason for the reddish appearance of the sunrise. It is not total internal reflection, it is not reflection of the light from the earth. So the answer is only C, scattering of light. See, that only the reddish appearance of the sunrise or sunset due to the least scattering of the red light. See, why red light only appearing at the evening? Because see, the least scattering for the red light, that's why the reddish appearance is observed. The red light have the maximum wavelength. Red is actually, if you take, so the red is the, see, the red is VIBGR, violet, indigo, blue, green, yellow, orange, red. VIBGR, visible spectrum. So in this VIBGR, see, only the color red is the only color which is having highest wavelength. So the least scattering for the red, that's why the reddish appearance will be there, okay, during the sunset or sunrise. So violet will have the 400 micrometer, but red will have the 700 micrometer. That is the wavelength. Wavelength of the violet is very less compared to the wavelength of the red. Red is the highest wavelength. That's why the least scattering will take place for the red. So the red appearance will be there because of the, okay, so scattering of the option B is the correct answer. Option B is the correct answer for this question. So next question. See, the next question, if you take, Yes, the sky appearance to be red. The sky appearance to be red at the time of sunset. The reason is, so the option, similar question here also. The blue color of sun rays is scattered by the away from the atmosphere. As the sun emits out only red color in the morning, white light is made to appear red by atmosphere. None of the above. See the same question here also. See the answer is because the blue color is the molecules are scattered from the sun more than the red. So that's why when look forward to the sun in the sunset we see red and orange colors because of the blue light has been scattered out. The blue light has been scattered out. So that's why the appearance of the red will be there in the sunset. This is the another explanation for the similar question. So next third question, the amount of light entering the eye is controlled by the dash. So the options are given: iris, cornea, pupil and crystalline lens. The amount of light which is entering into the eye controlled by only iris. Iris is the iris is the correct answer. The iris will be the controlled, which can control how much light can enter into the eye. That is controlled by only iris. And the remaining options like cornea and pupil, crystalline lens are the wrong options. These are the wrong options. See, the correct answer is only iris. So the next question. See the explanation. What iris exactly? Iris is the ring of pigmented tissue. The iris is the ring of pigmented tissue. Here, this part is the iris. See, iris is the part. This part is the iris. So, and this is the pupil. So, the ring of pigmented tissue, okay, see, which we will call iris. The iris opens and closes the control amount of light entering into the eye through the pupil. The pupil is the opening of the, just center where the light enters into the eye. So where the light enters into the eye, that is pupil, but iris controls how much light is how much light is entering into the eye, and all depends upon iris only. Iris is the answer for this question. So that's why option A is correct. So the next question, the rainbow is formed due to dash. Rainbow is formed due to, rainbow we observe whenever rains are coming or some thunders are in the atmosphere. It's a colorful phenomena. So that colorful phenomena, rainbow, formed due to dash, the reflection and dispersion of the light. Option A. And the next one is, see, refraction, reflection and dispersion of light. Third option only dispersion, fourth option only refraction. See, the correct answer is reflection, refraction and dispersion. All three phenomena. Reflection means when light is incident on any particular surface, returns back to the original medium, that is called reflection. So refraction is the bending of light when it travels from one medium to another medium. So due to the change in the speed of the light in the medium, we will call it as a refraction. Dispersion, the splitting of white light into 7 colors is dispersion. All three phenomena which makes the rainbow. The rainbow is formed due to the three different observed phenomena like, that is refraction, reflection and dispersion. That is the correct answer. The remaining answers, only dispersion is not correct, only refraction is not correct, only the option A, C, D are wrong answers, but the correct option is only all together reflection, refraction and dispersion. That is the correct answer. So next question, that is the explanation for this question. The rainbow is a meteorological meteorological phenomena. Rainbow is the meteorological phenomena that is caused by the reflection, refraction and dispersion of light. When water droplets or see light is incident on the water droplets, the resulting spectrum of light, that is like 7 colors, these 7 colors are observed. So it takes in the form of a multicolored circular arc. Okay, so that rainbow is caused by the sunlight always appear in the section of the sky, so directly opposite to the sun. Here the rainbow is formed always opposite to the sun, that you have to remember, that is important point. So violet, indigo, blue, green, yellow, orange. Okay, see some colors we observe, that is okay, spectrum type. Option B is the correct answer for this question. So the next question, that is question number 5. Okay, in the Tapas physics. See, in a room, the artificial rain is produced at one end and the strong source of white light is switched. So, at the other end, the observer of the rainbow, okay, see, the observe the rainbow observer must be where? Okay, the options are given here. See, if you see the option, look anywhere in the room. See, look anywhere in the room, from anywhere you can. So, if you look it, you will get the rainbow. Or look towards the source, you will get the rainbow. Or look towards the raindrops with the light source behind him. So option D, see, look in a direction equally inclined to the source of raindrops. If you observe, just now I told you, rainbow is formed when you are, so just opposite to that, so sun. It means sun is a source here. If you observe, the correct option is, see, the correct option is option C is the correct answer. Option C is the correct answer. See, look towards the raindrops. Artificial raindrops are falling in the room. You look towards the raindrops where light source is behind him. It should be light source is behind him. If you observe the raindrops, we observe a, okay, see, rainbow in the room. That is what the question. The remaining options are not correct. So the option C is the correct answer for this question. So the next question, if you take, the question is the color that is scattered the least, the color that scattered the least by the teeny particles and the atoms of molecules of atmosphere is, see, the color which is scattered least, I told you just now. Okay, so the colored which is violet, indigo, blue, green, yellow, orange, red, the scattered least one. Okay, so it's a violet only. The violet is the correct answer. Violet, okay, see, which is having lower wavelength, which is scattered least. Okay, see, the violet is the correct answer, but the green, yellow, red, okay, violet, indigo, blue, green, yellow, orange, red, this is the, see, visible spectrum. Violet is having lowest wavelength, that is, so 400 micrometer. See, red is having 700 micrometer. So 700 micrometer. So that's why violet has the, see, least scattering. The least scattering for the violet. You can remember. The next, the explanation for this question. See, there is a Rayleigh, there is some explanation. Rayleigh scattering. See, Rayleigh scattering, what it says, the refractive index depends upon the wavelength of the color. Refractive index depends upon the wavelength. It is inversely proportional to wavelength. Refractive index is inversely proportional to wavelength. So occurs when certain particles are effective scattering particular wavelength of the light. Air molecules like oxygen, nitrogen example are small in size, thus more effective scattering wavelength for the blue and violet. That's why violet is the least scattering. Okay, so that is the answer. Option A is correct. So the next question is the defect of myopia. See, the defect of myopia can be corrected by using dash lens. There is a concave lens, convex lens, and either concave or convex or complicated combination of the lens. See, which is the correct answer for this? Myopia is a short sightedness. myopia can be corrected by only, see, concave lens. Myopia can be corrected by concave lens only, we can correct myopia defect. See, the myopia defect can be corrected by concave lens. So the short sightedness. So see, convex lens is wrong option. All these are wrong options. Just explanation for this question. Yeah, here myopia can be corrected by wearing the contact concave lens. Here, normal eye, when light is there, incident on the eye, okay, so that it is instead of forming on the retina, the image not clearly forms on the retina. So when image forms on the retina, you can observe the clear picture. But a normal vision, okay, if a defected eye is there, the image could not be formed on the retina. So instead of forming the retina, so the behind the retina, okay, it is going to be formed. To make it correction of RIA, okay, so we have to use, there is a lens. That lens is concave lens. So once if you place a concave lens in between the eye and the light, where the source is there, so that concave lens manages to, so the image will be forms on the retina. So when image forms on the retina, we can see clear picture, we can observe the clear picture. So myopia defect can be so corrected by using the concave lens. This is an important question. So option A is correct. Concave lens is the we use for defect of myopia. See, similarly, hypermetropia defect can be corrected by so convex lens. Just a reverse to this, you can remember as a question. So the next question, the following is not a, which is of the following is not a primary color. Primary colors are what? Red, green, blue, or the RGB are the primary colors. CYB, can, yellow, and so gray, that is C, that we are secondary colors. Secondary colors here, yellow is there, yellow is the secondary color. That's why which of the following is not a primary color. Primary colors are, if you observe carefully, the primary colors are here, the red is primary, green is primary, blue is primary. RGB, red, green, blue are primaries. But yellow, if you take yellow, see this yellow color is the, so it is a secondary color. That's why this is the correct option for this question. So this is about question number 10. Then next question, if you take, yeah, yes, these are single correct answer type questions. Single correct answer. The first question in the toppers physics, a wire mesh, see, consists of squares, each of side 1 mm. It is placed at a distance of 9 centimeter from a magnifying glass. So focal length of 10 centimeter, it is viewed by placing an eye close to the lens. What is the magnification produced by the lens? Here the focal length is given. The focal length, and see, the focal length is 10 centimeters. The focal length is, see, the focal length is 10 centimeters. The focal length is 10 centimeters. See, object distance is 9 centimeters. Object distance is 9 centimeters. Object will be there on the left side. Focus is on right side, minus 9. What is the lens formula? 1 by f equal to 1 by v minus 1 by u. 1 by f equal to 1 by v minus 1 by u. Just substitute values. 1 by f equal to 1 by v. 1 by f, instead of f, what you should take? Actually, instead of f, you can take it as 10 centimeters. So So 10 centimeters if you take, so 1 by V minus 1 by minus 9. So if you observe carefully here, so minus into minus plus, so 1 by 10, if you bring 1 by 9 this side, 1 by 10 minus 1 by 9, see you will get here 1 by 10 minus 1 by 9, so that equal to, okay, so 1 by V. So from this you will get, if you observe, see 1 by V, you can take LCM, 10 9 ja 90, 9 minus 10 by 90 will come, 9 minus 10 by 90 is minus 1 by 90. So V value is how much it is? V value, I'll write here, I'll take, so V value, take another color, V value is 90, U value is 10. So now magnification, the question is magnification. So 90 is minus 90 you got here, minus 90 minus 10, U value is minus 10, minus 90 you got. So it means magnification is nothing but here M equal to V by U. M equal to, magnification is image distance by object distance, image distance by object distance. So 90 upon 10, 90 upon 10, minus minus get cancelled, it is 9, magnification is 9, oh, sorry, 90 upon 9 actually, object distance is, okay, not 10, it is 9, U is the object distance 9, that's why 9 10 ja 90, magnification is plus 10. See, option A is the correct answer, it is not minus 10, plus 10. So the remaining options are not correct, that's why, so the option A is the correct answer for this question. So thank you for listening my class, thank you. So thank you very much.